Welcome to our project, VHDL Learning Platform. Today we want to present you what we have already accomplished in our project and give you in short introduction what the project is about. The project is an easy-to-use learning platform for students at university or any other kind of educational institution that allows them to program VHDL and flash it and test it on actual hardware, because we want to give young people, no, everybody, the possibility to program FPGA boards from home over the web. And now to the part where the actual magic happens. At our university there's already a set up VELS platform, which is actually a platform where students can upload their VHDL files and get a simulated result back. And we wanted to improve that with actual hardware by grabbing the already existing VHDL file and loading it into our Zubo for testing purposes.
Actually, the script on the VELS server does dynamically generate new bit files for our FPGA, which will be automatically implemented in the P block. The user can watch the differences via webcam. Additionally, the user is also able to control and set inputs and outputs of his files. Here you can see the rewarded project overview. The project consists of two components, a partial configuration component and a block design, which you can see on the right side. These two blocks are meant to work together, therefore they have various connections to each other. Let's have a look at the block design. It consists of a Zynq programmable system which is capable of controlling all existing EXI devices in this design. Actually, this also has a web server which provides a user interface. The hardware ECAP block is used to flash new bit streams into the partial design. This allows the Zynq to dynamically program the partial reconfiguration block, which is implemented in the project view. Another part is the AXI GPIO, which is used to test the implemented partial reconfigurations. These can be controlled by the user over a web interface. The last part are the dynamic clocks, which can also be programmed by the Zynq to provide various frequencies and maximum flexibility to the user. Actually, this was my part, and now to the part of my colleague, which will be the software part.
And now welcome to the software part. What I'm going to show you today is what's already been implemented, and that's a user management and a way to handle users. Here you can see we have the default user. Now let's switch to the Felix user. Here you can see Felix has 3 pins enabled at the moment, and he's capable of toggling pin 0 on and off. To switch to a partial design, what's going to be the main feature, we need to command that command and then flash the test partial bit file, as you can see right now. This enables us to have basic input-output tests at the moment. So you can see the in flag is also on if the pin is toggled. As well as another user, because another user is capable of working on the same file at the same time. So now we're at the user Philip. He's also capable of switching other LEDs, which are connected to the other RGB LED. And now if Felix wants to enable his bit again, it's also possible. For debugging purposes, we also implemented an admin user, which is capable of seeing every LED and every pin that the connection at the moment has. And that sums up the project.
I hope you enjoyed the video, and thank you for your attention.